Namaste, this is JVN Dr. Vishal Saxena, Associate Professor in Mathematics, Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss on the session 2-point form of a straight line, and this module is a part of the course Elementary Mathematics under the program of BSc Agriculture, BSc Honours Agriculture first semester, and integrated BSc Agriculture first semester of the university. And we can also say this is an important part of mathematics and also included in the various other courses of the university as well. And so first we discuss about the topic of like a straight line and its equations. So straight lines or a straight line can be defined by the many different form by the equation. So these equation may be like in the 1-point form or the 2-point form or the slope form and slope point form. So just we are having the different equations, different formulas in the case of a straight line, like the slope form of the straight line is called given by y equal to mx plus c. Y equal to mx plus c is the straight line's equation in the slope form, where m is called the slope of the line and c is called the y-intercept. While the slope point form of the straight line is called the equation y minus y1 and is equal to m into x minus x1. So this slope point form, or which is also known as the 1-point form of a straight line, this is given by y minus y1 is equal to m into x minus x1. So why it is called 1-point form or the slope point form? Because there are the terms m and the point x1 y1 is there by which the line is passing, through which the line passes x1 y1 point, and m is the slope of that line. And as all we know that m, which is the slope of the line, is also just given by tan theta. So slope is a concept of tan theta, where theta is the angle made by the straight line with the positive x-axis. So theta is the angle made by the straight line with the positive x-axis, and x1 y1 and x1 y1 is the point through which the line passes. Now just we are coming to the topic of the 2-point form. In the 2-point form, just we have seen the slope point form, where is the term of m, and if this term m is replaced by the another term like y2 minus y1 upon x2 minus x1, so then this form, the slope point form, will be called the 2-point form of the straight line. And for this we share some slides to explain this in more better form, because the mathematical concepts are coming there. So just we will take some slides like the 2-point form is mentioned here, and in the 2-point form just we can see formulas are showing there. So if the line passes through the 2 points like x1 comma y1 and x2 comma y2, then this equation of a straight line in the 2-point form can be given by y minus y1 is equal to y2 minus y1 upon x2 minus x1. So y minus y1 is equal to y2 minus y1 upon x2 minus x1 and multiply by x minus x1. So this is a straight line equation in the form of the 2-point form, where the 2 points are just known that through which the line passes, x1 y1 and x2 y2, and this equation can also be written in the another form, and where just we can see this this equation is given in the next term, in the next below this it is written by y minus y2 is equal to y2 minus y1 upon x2 minus x1 and x minus x2. So it means the point the slope by m m is the slope like which is written by y2 minus y1 upon x2 minus x1. It is a formula of the slope m, and the term in the above equation it is given by y minus y1 and x minus x1, while in the second equation it is written by y minus y2 and x minus x2. So just both equations represent the same straight line, and we can use any one of the equation. Both will give the same answer, and here just the difference between the 2-point form and the one slope point form is that the m is equivalent to like y2 minus y1 upon x2 minus x1. And as also we know that m means slope is equal to tan theta, and which is given by various different concepts also, like the concept of the derivative differentiation. So m is equal to like dy by dx, and dy by dx means the derivative of function y with respect to variable x. And if we have to find the slope at a particular point, then just find out dy by dx at that particular point. Suppose just the point is like 2, 3, then we have to find dy by dx at the point 2, 3, and which will show the slope at that point. So these two equations are showing the 2-point form of the straight line, and now we take some examples to understand this topic of the 2-point form in more better way. And in the first example we are having the one line, we can see there this line is passing through the 2 points 3, 2 and 1, 6. So these are the 2 points through which the line passes, and having the slope like y2 minus y1 upon x2 minus x1 can be determined. So if the question is just asked for the determination of the straight lines equation, then we can use one slope point form also or the 2-point form also, and just the difference is of the term m. In the slope point form m is used, in the 2-point form m is not used. In the place of m, y2 minus y1 upon x2 minus x1 will be used. So first we take the 2 points like x1 y1 is taken as 1, 6 and x2 y2 is taken as 3, 2. So we will find the term of y2 minus y1 upon x2 minus x1 as m. This is equal to like 2 minus 6 upon 3 minus 1, and which is equal to minus of 2. And just when we solve, when we put these values like x1 y1 and the value of like m2 minus y2 minus y1 upon x2 minus x1, that is m, which is minus 2, in the above equation, that equation written as y minus y1 is equal to m into x minus x1. So this equation is called the slope point form, and we are putting the value of x1 y1 and m in this equation, and we will find the result from this equation. So we will have y minus 6 is equal to minus 2 into x minus 1, and when we solve this equation, then we will get the result, the answer as y equal to minus 2x plus 8. So this will be the result of this question. This will be the answer for this question. Now we take one more example to understand this more better. The question is asked in that way that just prove that the points A, B and C with the coordinates given that already 1, 2, 3, 4 and minus 2, minus 1. So we have to prove that these points are collinear points. So for this question, if we have to show that these points are the collinear points, then how can we show that? Just first we will make what is concept by which we can show that these 3 points are the collinear points. So many different ways are there, by which we can show that these 3 points are collinear. First of all, in this question we are going to solve by this way. First we will use the 2 points A and B, by which and just we will make the equation of a straight line. Means we will find that the equation of a straight line which is passing through the point A and B by the 2-point form. And then if the third point C will lie on this line AB, if the 3 points are collinear and we have to show this, then if the third point C will lie on the straight line AB, then definitely the point C will satisfy the equation of straight line AB. And if it will be satisfied, then it means the 3 points will be collinear. So first we will find the equation of straight line AB. And how can we find the equation of a straight line? The point A and B can be taken as the 2 points like x1, y1 and x2, y2. And just we have to use we have to put these 2 points in the formula, in the 2-point formula. Y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. So it is shown there, y minus 2 is equal to 4 minus 2 upon 3 minus 1 into x minus 1, or this is given by x minus y plus 1 equal to 0. This is given by x minus y plus 1 equal to 0 is the line, is the equation of straight line AB. And now we can see if the point C will lie on it, then the coordinates of the point C will satisfy this equation. And if we put the values of coordinates of C point on this equation of line AB, then we can see there minus 2 minus 1 plus 1 equal to 0, and it means just we can see there this equation will be satisfied, and hence the 3 points A, B and C will lie on the same line, hence these are the collinear points. So in this way we have shown that the 3 points A, B and C are the collinear points, and we have just in another example we have just determined the equation of a straight line which passes through the 2 points, and we have found it by the 2-point form or the slope point form. Just both equations are equivalent to each other, only the difference is of slope m. So this part of the 2-point form or the slope point form is very important part of a straight line. And just how can we make the command over this topic, because by practice so students are advised to first understand the concept of the topic, the meaning of the topic, and how these different forms are just related with each other, because there is a correlation between all these forms. So they have to understand and how these just forms or the concept of straight line is useful in the various other fields, because all we know that mathematics is a very important subject and is foundation of the other subjects like computer science or the physics and the various other subjects. So because this the derivations of all these subjects are based on the mathematical concept, and therefore the elementary mathematics is always used to study the various other subjects. And we have seen the concept of a straight line today in different forms, and students are advised to take some numerical problems also, because the numerical questions, because in mathematics just questions are very important, how to solve the question, because this will give you the concept of that part. And the numerical questions will be asked in competitive examinations, the objective questions as well as the descriptive questions. To students must solve some numerical problems to understand this topic in better way. And with this I conclude my today's session. Thank you.